This is the two-dimensional motion lab. It's also called the projectile motion lab. In this lab, we're going to use this gun to fire these little yellow plastic balls. At the moment, the target I have is on the floor, and I will zoom in and let you see the target in just a minute. There is a plumb bob hanging right here, and I will zoom in on that in just a minute as well. This tells me what my angle of inclination is for the gun with respect to the horizontal. So I'm starting here and I'm inclining the gun at some angle to the horizontal, and that's what the plumb bob tells me. I'm going to put the plastic ball in here. I'm going to take this ramrod, and I'm going to go until the little yellow indicator here, which you are not able to see probably from this angle, is in the third slot. If you read your manual, it will say there are 5 slots in the little yellow indicator bar should be in the third. If we go all the way to 5, that will shoot, good distance. If I point it straight up, I can hit the ceiling. I don't want that much power today. So what I do is I cock the gun. I do not look down in the gun, and I will pull this string, which attached to this lever, and I've just fired the gun. Now, let me first zoom in. On the plumb bob. And you can see that the angle, let me just slide over just here, there we go. The angle, this is the center of curvature is right here where this little hole is. And the angle is about 63 degrees. So this gun is inclined at 63 degrees to the horizontal. Now, let's take a close look at the target. This is a piece of carbon paper, and underneath it, I've got it taped down so it doesn't slide. Underneath it is a legal size piece of typing paper. When the ball hits the carbon paper, it will leave a little mark. I've got 1, 2, 3, 4 marks already labeled. That will be for the data that is in the first table there in your lab manual. But what happens here is that when I fire the gun, I get these little marks. Okay, these 2 I've fired since I collected the first 4 data points. What happens is I measure the height of the gun. It's 89.5 centimeters. That will be in the table. And then I measure the distance from a piece of tape directly under the gun to the, oops, I got it backwards. To where the marks are here on the paper. And I just measure along here. I'm not sure I'm lined up completely down at the other end, so I'm not going to actually try to make an exact measurement. But this is how these are done, okay? So what I'm going to do now is I am going to show you the data that I have collected for investigation 1.1 on page 68. There should be, in your lab manual, a table. I took 4, it says to use a minimum of 3 to take an average. I used 4. Now the height of the gun muzzle is not going to change, so that's going to be this first column, y, in centimeters. Column X is the 4 measurements you saw marked. They're on the paper. They had label 1, 2, 3, 4. Okay? And then this next column is the muzzle velocity of the gun, which you're going to need to calculate to do the rest of the experiment. This bottom line is for the averages. I've done the first one for you. What you need to do is calculate the velocity. Do that using the equations you derived on the previous 2 pages. If you need some help with that, you can probably find some help in your textbook. It's a common derivation. Calculate the average distance, average velocity.